Polynomials can have more than just a single variable in common. They can have a bunch of stuff in common. Notice how there's a parenthesis of 9x minus 1. That's a binomial, and they both have that in common. What you could have done was say happy face to the fifth, happy face to the fourth, and recognize that they both have a happy face in common. All I did was replace the 9x minus 1 with a happy face. This is just 5 of them. This is just 4 of them. So in this case, our greatest common factor is the happy face. And obviously it's not really a happy face, but the question is once you identify, all right, I got the happy faces in common, you look for the lowest exponent. So this was a 5, this was a 4. Lowest is 4. So whatever the happy face is, which is 9x minus 1, to the fourth power, that's the amount that we have in common. So what we need to do is divide out that value. So I'm going to put my happy face to the fourth power, and that's going to be in front of a set of parentheses. So I need to divide out this happy face to the fourth power on both of those. So if I divide anything by itself, I just reduce the powers. So this 4 reduces with the 5 up here, and that's going to be one happy face to the first power here. So happy face to the first power. And then plus the 7, this is happy face to the fourth power on the bottom. This reduces out anything, happy face or whatever, in math divided by itself is 1. So these divide out and it's 1, and so plus 7 is left. Now I did all that work with a silly happy face. The happy face is actually the whole time what was behind the happy face. It was 9x minus 1. So wherever there's a happy face here, I could just replace it with 9x minus 1 in parentheses in place of those happy faces. So right here, in these two locations, you put 9x minus 1. So I'm going to erase those happy faces and put in their place 9x minus 1. And this would be fully factored using my binomial as a GCF if there was nothing left to do in this parenthesis. Out in front, I forgot to put my parentheses. I apologize. Where the happy face was, the whole thing to the fourth power. And in the back here, there's a little bit left inside of this parentheses. There's some math, some simplifying that can be done. We've got 9x minus 1 minus 7. I can rewrite that by subtracting the 1 from the 7 to be 9x plus 6. And then what we'll have here, sorry, let me write over that, is 9x minus 1. I don't know why I put minus 1. Is supposed to be what's in there. To the fourth power times 9x plus 6. Now, I have to be careful because the problem says factor completely. If I had just said, hey, factor the binomial factor, I did that part. But there's a little bit more left over here because the 9 and the 6 have a GCF of 3. If it was a standalone problem and I was off at the beginning doing 9x plus 6, I would have said that they had a common factor of 3. So I'm going to say 3 parentheses and then divide each of these by 3. 9 divided by 3 is 3, and then x is still there. And then 6 divided by 3 is 2, so plus 2. So this separate problem is actually what needs to be taken care of after we do the 9x plus 6. So this is going to be replaced with the factored form of 3 times 3x plus 2. And then in front of that is still my 9x minus 1 to the fourth power. Now that 3 I kind of have squished in the middle there. Usually we put that out in front. So I would put 3, and then it doesn't matter what order the binomials are, x minus 1 to the fourth power, and then times 3x plus 2 is probably the best form for this final solution. So this is how we do binomial GCF. I don't actually use happy faces typically when I'm doing it on my own, but it makes a good point that we can put anything to a power and recognize that it is in common and can be factored out. Working through this problem, we're going to recognize that 10x plus 7 is in a parenthesis in both terms. The terms, again, are separated by addition or subtraction, in this case, addition. And so I want to recognize my GCF is the thing that's in common. In this case, it's a binomial, and it's the lower exponent. So the GCF is 10x plus 7 to the fourth power. And so I divide each term by my GCF and write my result as a product of the GCF 10x plus 7 to the fourth power times whatever the result of the division is. So I divide 10x plus 7 to the fourth power from the first term. And when I reduce, all that happens is these 4 cancel out with 4 of these ones to be 1 left over. So I put that as my first term in the result of division. So 10x plus 7 to the first power, which you don't really have to write that part. And then the second term, when I divide it by 10x plus 7 to the fourth power, that part reduces out completely because anything divided by itself is 1. Just the 5 remains, so plus 5. And just like the other problem that we did, when we have completely, we have to watch for anything at this next level. When I add my 7 and 5, I'm going to get 12. So this parenthesis is actually 10x plus 12. So I have to watch. So I'm going to just put a line through that because that's actually 10x plus 12. I have to watch for common factors at this next layer and to notice that the 10 and the 12 are even. So at least they have 2 in common. And that's it actually. But we have to factor out as kind of a standalone problem, 10x plus 12, and then recognize that its GCF is 2. And so you divide 10 by 2 and get 5x, and divide 12 by 2 and get 6. And so this 10x plus 12 back here can be replaced with 2 times 5x plus 6. And then up next to it should still be my 10x plus 7 to the fourth power. So you can put a little dot next to that or just extra parentheses. It doesn't really have to be arranged, so I'm going to leave it like that. This is the correct fully factored version of this polynomial. So in this example of a binomial GCF, we're going to pay attention for a common mistake that people do with greatest common factors, and that is when our greatest common factor is a whole term. And so what our brain says is probably right away our GCF, after seeing the previous examples, is 9x minus 4, and then to the first power because there's the lowest power of 1 there. This one's squared. So what our brain says and what students do, common mistake, is we just jump right on down to our answer and we say, all right, the factored form is 9x minus 4. I'm just and our brain says pull it out. And so when I pull it out, there's nothing left. And then I do it on this one. So then I divide this one and we get negative 9x minus 4 to the first power. And then you might distribute the negative and continue on from there. But before we get too excited and continuing in a wrong direction, this is incorrect math because we don't pull out our first term and just put it in front. We're dividing out our greatest common factor. So we have to be very methodical about what we do with this. And the doing is division. Factoring is division. If we didn't do any dividing and we're just pulling out, we're not quite grasping the whole thing. So we need to write our greatest common factor in front of a product with parentheses to the first power. And then in here must be a result of division. And so we need to divide each term by 9x minus 4. And if we divide anything by itself, we ought to get a 1. If we don't come up with this 1 right here, we have errored. So we need that 1. And then this negative 9x minus 4 divided by 9x minus 4, you reduce a power. And so this one will reduce by 1 power. And then we have a negative 9x minus 4 that goes back here. Now be careful. That negative sign needs to distribute into a parenthesis 9x minus 4. So I need the parentheses so that I can distribute correctly and get this to be a negative 9x plus 4. So it's 1 minus 9x plus 4 that's actually inside this parenthesis right here. And then I'm going to rewrite this to be the 1 and the 4 go together to make 5. And so it's going to be negative 9x plus 5. And then I'm going to bring this parenthesis up next to it, which was 9x minus 4. Now, I would say this problem is done. You could, if you wanted to, if you didn't like that negative sign that's hanging out inside there, you could factor that out. And then these signs will change. But there's no need because factoring completely doesn't necessarily mean that you have to pull out the negative. But if you wanted to, you could. And I'll show you what that answer is right above here. I'll erase a little space. If I factored out the negative from here, pulling that out, it would make this a positive 9x and then a negative 5. And then this 9x minus 4, you would need to multiply it. And because I put just a minus sign there, I'm just going to put it in the back. So I'm going to actually trade spaces with this and make this a 9x minus 4. And that would be if you factored out the negative. It didn't make the problem or the answer any better. Either one of these should work for you.